Hey everyone, welcome back to Web3 Deep Dive Podcast. Today I'll be speaking with Arie Trouw. He is the co-founder of XYO Network. We'll be discussing sovereign data, sovereign internet, and how that relates to both Web 2 and Web 3. Before getting started with today's interview, I'd also like to remind you guys to please like the content that you're seeing today and to subscribe to the channel so you stay up to date on all of the new and exciting upcoming interviews that I have in store for you. Okay, without further ado, let's get started with today's episode. Hey, Arie, how's it going?
Pretty good. How are you doing, Rachel?
Doing well. Thank you again for joining me today on the podcast. I'm so excited to be speaking with you.
Oh, thank you very much. Thanks for having me here. I'm very excited about this too.
Yeah, of course. So before we get started, let's talk a little bit about your background, Arie, and then we can go into XYO Network and find out what you guys are doing. But, how did you get started in the Web3 space?
Well, Web3 space has been, really the fairly more recent part of my career. I've been a software engineer and an entrepreneur for a couple of decades now. And so I've really been a proponent of sovereignty or sovereign technology in general, even prior to the Web3 craze that's out there. The ability for users to control what happens on their computer, where their data goes, and that sort of a thing. And then when Web3 came out, really, I got very interested in that because it was one of the things which was very difficult for us to accomplish with some of the technology we were working on. And so we really embraced it because it was a very big step forward in data sovereignty. And in my opinion, that's really what the goal of the original Bitcoin founders and all those were to establish a sovereign payment method in their case, but just to embrace sovereignty as far as technology goes in general.
Got it. And can you explain what XYO Network is and what the goal of the company is and what the network is doing?
So XYO is based off of our white paper, which uses a thing called proof of origin chains. And so it's not typical compared to like most of the projects out there where they use a shared ledger. We use ledgers that are not necessarily shared. They're shared as far as I can send items to other people, but you don't have one where you have to have a consensus necessarily or some sort of a methodology to be able to establish that as the chain. So we do use other chains to check into so that we can make sure we get permanence from that standpoint. But we really focus on data sovereignty and data provenance. So the provenance aspect of it is the proof of origin. So where did this data come from? Who signed it? Who generated the data? And what was the sequence of the data as far as how it went? So we did start off with some location technology stuff to show that, like tracking the location of something over time. And then we've moved on to some really other very exciting aspects of that. For example, you can use it to store data for a chat session or like a tweet, and then you can see the whole history of where a person tweeted, and you can't alter that history. So it provides that permanence and provenance for the data. So we're really focusing on that, and we're now working on a variety of tools to be able to provide other solutions than just location as far as sovereign and proof of origin concepts.
Okay, so right now XYO Network is focused on location data.
It's the current version of it that's out there that we use for our coin app, for example. It was on location data, but our 2.0 version that just came out recently focuses on all kinds of data. It's not specific to location data. Location is obviously a very important part of data because it's how you tie data to the real world. You have time and you have location. So you have XYZ coordinate system, or XYZT, basically coordinate system of where did this happen? And that context really is very important for most data, not just location data. So location and time is really something that's metadata that revolves around the other data. And so that other data and the origin of that's what we're focusing on now.
Okay. Let's talk a bit about data sovereignty. Let's talk about the concept because I want the listeners to understand what exactly data sovereignty means and why it's important.
So sovereignty, the idea behind it is that you have control over your own thing. So, for example, like in the United States, the idea of your home is your castle, sort of a thing, where you have sovereignty. You can make rules in your own house. Now, if you go out in public and you have to share rules with other people, that's a different story. You have to have a democracy, or you have to have some sort of a way of determining what those are. But the idea of sovereignty is that I don't have anybody else who tells me what rules I have in my house necessarily. So for example, on your computer, if you have a data store on your computer of all your images, for example, you don't want to be in a position where Facebook or Apple or somebody can cancel your access to your own images in that situation. And especially now with the cloud being much more prevalent, a lot of people don't realize that both access to their data, as far as using it for training sets for AI or for targeting for advertising and that sort of a thing, is something which is hard to control. And then, of course, also the ability to make sure it doesn't go away or disappear. And you want to be able to have control of that. So the idea of a sovereign internet or a sovereign system is that you don't have to have a middleman to do things. And in most cases with Web 2, you have to have a middleman. You have web servers, you have Google servers, you have your Microsoft servers, your Facebook servers, and all that. And so you can't run anything without those servers. But there are technologies where you can connect two computers on the internet and have them talk back and forth. And the early internet actually was much more that way. Each person would run their own email server, for example, as opposed to having a Gmail where you would log into. So we kind of went from Web 1.0 was kind of more sovereign in many ways because everybody had to make their own system. Then Web 2.0 became much less sovereign, but it also provided a lot of value in the fact that you have easy to use solutions where you didn't have to roll your own or provide your own system there. But it also comes with consequences where you don't have control over those things. And then now Web 3 really focuses back on onto sovereignty, but with some performance costs and actual costs. So, for example, using Ethereum as a backbone for a piece of software will cost you a lot of gas to run it. So there are some downsides of trying to pursue that, but we're pursuing our approach to sovereignty in a different way than shared ledgers.
Okay, got it. And how is XYO? Let's talk about XYO Network's approach to data sovereignty. Explain how that works.
So the idea of it is that all the data that you have, or you want to share, it's signed by you. So one of the most sovereign concepts in Web3 that people see is a wallet. So I don't have to go and ask somebody permission to give me an account or give me a wallet. I can just run an algorithm on my computer. I come up with a private key, which you have to keep private, of course, and then you have an address that comes along with that. So for me to create an Ethereum or a Polygon address, or if I'm using a Bitcoin address I want to use, it's completely sovereign because I can generate one without anybody else knowing what it is because it's just math. So that's zero knowledge proofs are very similar to that as well, where I can actually create something where a person knows what's going on in there without having to verify it or validate it with a server. So we can take the next step on there, and we store all the data in XYO in these proof of origin chains, which have hashes and they're linked, and then also signatures and are bound witnesses. So, for example, if I see a piece of data and I want to say, well, I want to be on record that this data was true at this point in time or this location or just in my server, I can go ahead and sign it. And so now for somebody else to verify that this data came from me, all they have to do is be able to verify the signature that's on there, which you can do without asking another server. So for any of the problems that are out there, whether it's authentication or it's privacy or all those, if you can do it with a sovereign solution where I sign things or for me to make it available to you, you have to decrypt it based on a key I give you. You can have two parties that are going back and forth on there without having to have a middleman do anything. So then it's complete freedom for you as far as what you want to do with that technology.
Can we talk a little bit about use cases and maybe even use cases that are happening today on the XYO network?
So, for example, one of my favorite use cases is simple chat, right? And there are some peer-to-peer chat protocols that are out there. It's a very compelling problem right now for people because of deep fakes, or you don't know where it came from on Twitter. They have to go through and they have to scrub the data. But if all that data was signed and all that data was peer-to-peer, I can filter out the people I don't want to see on there necessarily, and I can have a family chat, which is just private to my family, for example, or I can have a work chat that's private to my work. You have that to some degree with like Slack, for example, but then Slack also has access to all those messages and they're all available to them as well. And they can also discontinue your account. You have to continue paying them. So a very similar example is video cameras for a home. People get security cameras. If you get a Ring camera, for example, you have to pay $5 a month and it all goes to their server and it gets stored there. But then there are solutions like Ubiquity where you get a one-use server for your home, and all the cameras in your home actually records to your own server on your own hard drive, and it doesn't go into the cloud anywhere. So the benefit there is if the internet goes out, first of all, it continues to record the video. You don't have to worry about connecting to the internet. And two, that never gets deleted by somebody else. They can't accidentally remove it, or they can't look at it without your permission. We've had problems like that with Roombas, for example. Roomba got caught having people review video from Roomba that's supposed to be used for just positioning of the device that would actually see people in the bathroom or in the bedroom. So you don't want a camera roaming around your house that's sending all this video to the cloud. So those are the use cases. So anything where you really don't necessarily want to put something in the cloud is a use case for us. And we do simple examples where we can get prices for crypto, for example, from different sources, and then store them locally for you, and you can maintain those. Photos is one thing which we care about, where a person can store photos locally and then share the ones that they want to without having to have them on the cloud, but also be able to back them up to the cloud if you want to make sure you don't lose them as well. So you can have duplication. So the cloud isn't all bad. It's good for backups, good for duplication, but it shouldn't be your only place where you actually have something. So any of that data where a person wants to store it can be stored in our system. We have an NFT tool, for example, where we go out and we get all the information from the NFTs that are out there, and then we store them for you locally, or we also have a mirror of it on our servers. And the thing that's neat about that is it shows you what's actually at that NFT. So if a server has gone away for NFT, some people don't realize that most of the data for an NFT is actually stored on Web2 servers. There's a Web2 server that has the metadata, the image is on a Web2 server somewhere. Some people put it into IPFS, but IPFS also can be lost if no one pinned those things that are there. So we store those, and we can show you the authentic, like this is actually what's there, as opposed to if you go to OpenSea, it's whatever in their cache. If they've cached the image. So people will sometimes buy something on OpenSea, not realizing that the server that actually provides the data for it's gone away, and the NFT is actually gone.
Right. Yeah, no, it's interesting. And so, Arie, do you think, given this technology, do you think the concept of a sovereign internet is actually possible?
I think it is. It's difficult. Don't get me wrong. I've been working on this for a few years now, and it's not as simple as people would want it to be. But that's what's part of the thing that makes it special, because we've gone so far down the not sovereign internet, and it's getting more and more problematic for people, that we have to kind of gradually figure out, well, how do we go to, because making a full sovereign internet is actually pretty easy, but it's going to be slow, it's going to be expensive, it's going to be all those things. So how do you make a sovereign internet that's actually comparative to the normal internet, where it's just as fast and it's just as inexpensive to use? That's where it becomes tricky, and shared ledgers become a problem for that, because everybody has to validate the same data over and over and over again. So the cost of making a shared ledger is extremely high compared to just storing it in the Mongo database. So overcoming those cost barriers is really what we focus on. And so there's faster computers now. There is, so if it's 10% slower or 10% more data you have to store, it's fine, because data is so cheap now. But if it's 10 times as expensive or 100 times as expensive, it's problematic at that point. So really getting a sovereign internet that works to the point where a person expects it to work, that's what the hard part is. And people's expectations of how the internet should work is pretty high at this point, because it works pretty darn well.
Right. And I mean, I'm guessing, with this idea of sovereign internet, XYO Network is just one piece of that puzzle. There's probably other elements that need to be in place as well.
Yeah, well, there's definitely other parts that are already in existence. Like IPFS, for example, it's a sovereign data storage protocol. So I can have an IPFS server, and you can have an IPFS server, and we can share data that's on there, for example. Even just the signing concepts of Ethereum or Bitcoin are sovereign in many ways. So there's a lot of sovereign technology out there and bits and pieces, but no one's really put it together into a useful system where I can say, well, I want to replace real use cases, whether it's social media or it's chat or like Twitter or photo storage or any of those things, in a meaningful way in a sovereign internet setting. Some people have tried making a sovereign social media, for example, but they still end up on the shared ledger, so it becomes painfully slow and problematic. So it's difficult to actually replace the features people want and they expect from Web 2 with sovereign Web 3 features that are just as good, if not better than those.
With the sovereign internet, are there tokens involved with this model?
So fundamentally, you don't have to have tokens. Kind of like if I set up my own Ethereum blockchain and I've Ganache running, I can make my own payment methods there. But the place where it becomes important to have a token is to be able to pay for services that need to be grouped together. So, for example, if there is a check-in into an Ethereum blockchain, we have to pay for that. And if I want to for example, use some of your processing power. So say you have a farm of a bunch of GPUs and I want to use it to train some I can pay to use that rather than setting up my own items on there. So in some cases, there are kind of SaaS type solutions in a sovereign internet where a person might want to say, well, I want to use this resource that's shared and pay for that. But the way that it takes the data and provides the answer to me is in a sovereign way where I can verify afterwards that it's actually true. And this is actually one of the interesting ones for us is the AI training where people really want to have a personal AI assistant, but the problem is to get a really good personal AI assistant, you have to give it all the data that you have. So you don't want to upload every detail of every thought that you have to ChatGPT so it can become more familiar with you. You'd rather have that data stay on your own computer and in your own control, and then train an AI from there. Or even in the case where it's just IP, whether it's photos or paintings or that sort of thing. So AI training is, I think, a very important thing there, but not everyone's going to have necessarily the horsepower to train it. So being able to buy some horsepower from somebody else is where the token comes into play. So XYO is a token, and it's really meant for the exchange of either storage or processing on our system.
I see. Okay. I want to back up a little bit because when I first learned about XYO Network, it was years ago. So the network has been around for a very long time because I've been in the industry since 2017 and I learned about XYO Network early on. I remember the concept of location data and these certain use cases that were happening on the network then. And I don't know if they're actually happening on the network now, but what are the use cases with location data on XYO Network specifically that are being leveraged today?
So one of our original location aspects of it was we had a thing called XY Find It, which was a product that was like a kind of like the Apple AirTag, and we've actually sunset that product since we've had it, but we've had it for probably about eight or 10 years for the existence of this company. So even prior to having the Web3 aspect of our company. And that was very location based. So it was, we obviously had location check-ins for people of where their items are, and those devices would report those. So that's what one of our first use cases was there. We also use it for Coin. So we have a product called Coin, which is an app you can install on your phone. And in there, you geomine. We call it geomining because where you are in the world, you say, well, I want to mine this, but you can't mine remotely somewhere else. And so we want to verify that a person's actually where they're at based on various things that are in there. And so we record those different aspects of data from them, and we can actually verify after the fact whether or not they were being Byzantine in their approach to actually collecting coin in the Coin app. So we do use location for that because the Coin app is a very location-centric sort of a solution. But we felt that location was too narrow a focus for what we had come up with. That's why we really expanded to the other aspects of data as well, and just made time and location something which given a piece of data, you actually want to bolt it on in many cases. So, for example, with the Coin app, the action that the person's recording is the fact that they're geomining a certain place, but they're geomining. And then the question is, well, when did you geomine and where did you geomine? So they're almost like adjectives that go along with the verb. The verb isn't location. Location is a noun or an adjective for something. It's not a verb. You don't location yourself. If anything, you stop somewhere or you geomine somewhere or you go eat somewhere. So if I go eat dinner at a restaurant, the eating dinner is the verb, so the data is actually being produced. But where you ate and what time you ate is important aspects of what goes on there. So we want to store both of those. We don't want to just store the location and the time. We want to store the actual action and the data that goes along with that as well.
So if I wanted to leverage XYO Network, do I need the token if I was using something that was recording my location data? Would I actually need to hold an XYO token to do that?
Well, the way it works in Coin right now is we have a two-ended market system there where basically we have partners that pay for access to data and for information there. So a person who's using Coin, they basically can say, well, I want to expose my data that I'm doing while I'm geomining and get paid for that. So we give them Coin in exchange for that, and then they can redeem that for XYO. So basically, XYO is the intermediary in that data exchange there. So people who want to use aggregate data from all of our Coin users, they basically pay in XYO, and then we give the XYO back to the people who produce the data.
Got it. Yeah, I'm asking because I'm wondering if it's challenging. The concept is very interesting, but if it's challenging kind of bridging the Web 2 world into this Web 3 world with all the different elements. What are your thoughts on that?
It's definitely very difficult because you can't ask somebody to just use something new. You can't be like, well, you've come up with something way better. Just stop doing it how you're used to doing it and start using this new system. It's kind of like a person moving from email to chat. Like we also have email, but no one really likes email, but we also have email. But you also can text things, or you can use WhatsApp or different chat devices. So making it so that it's not a choice a person has to make where I have to use this or the other one, where you kind of can integrate it into their existing workflow in many cases. So one of the things we're doing is we're making an entire, we call it XYOS, where it's like basically it's a view into using our system that runs inside the browser. So it's easy for you to basically spin up a node and start using XYO. All you have to do is go to a certain website, and then it runs in workers on your browser. So it's still running locally on your computer, but it's the way you turn it on, or the way you get it is you just go to a website and the code comes to you and it runs locally. As opposed to saying to somebody, hey, go and install this Docker component and then run that on your computer, which is a lot more difficult. I don't know if you've ever tried installing an IPFS instance or a node for Ethereum. It's not for the average American. It's for people who are technology enthusiasts who can follow those more difficult instructions. So we're trying to really make it that the install process is something which is easier than installing a Windows on a computer, for example.
Got it. Let's talk a little bit about the other data capabilities of the XYO network.
So the kinds of data we store in there, the first thing we do is archivists, where they're basically to store just pools of data, large amounts of data. But then we have a thing called diviners, and what they do is they go look at the archivists, and they have certain purposes. So, for example, bound witnesses being one of the components that we work with, we have diviners that will go and pull all the bound witnesses out of the pool of data in the archivist. But you can also say, well, I want to get payloads of a certain schema. So you can say, well, I don't want all the data. I just want data about, say, temperature, or data about images, and say it's thumbnails or whatever. You can say, well, given the schema, just give me those, and then give them to me in the same sequence there. So we have these different components. We have an archivist, which is a pure storage, kind of like an S3 almost on Amazon. And then we have diviners, which are more like a processing aspect, where you take existing data that's in there and you process it either into new data or you find it for somebody. So all of our indexing is done through diviners that are there. We also have things called sentinels, where the sentinel runs and it calls the witnesses to go and gather data. So if I have a witness, for example, that goes and checks the temperature of my pool, and I want to run that every 5 minutes or something like that, my sentinel every 5 minutes will say, hey, to this witness, go check the temperature of the pool, report back to me, I'll save it to an archivist. So it's really the bridge between the witnesses and the archivists, as far as how often do I want to collect data, how often do I want to store it. So it's the automation really that runs inside the system. So those are all the different aspects and components that are in there. The witness, what I just mentioned, there's the most fundamental, like, how do you take something from, that's the Oracle part of XYO. How do I take some data from a different server or from the real world and onboard it onto XYO? So the witnesses really import that data. So we can import data using witnesses, we can process data using diviners, and we can store data using archivists. And they're all stored in this multi-chain tangle where you can have multiple parties even sign the same thing. And so you can have certainty of where it came from, what it is, and the fact that it didn't change, without having to have a shared ledger that everything flows into.
Is that multi-party computation?
Well, what it is multi-signatures. So what we do is, for a bound witness, if there's a, say, for example, multiple people are at the same location, they can all take the temperature there, or they can take a picture with their phone, and they can all sign that datagram and say, well, yes, we all attribute the fact that, or we all, claim that this photo is true, and it was taken at this time at this location. So that way you have more than one party actually attesting to the validity of something. And the thing which is nice about that is that's how you kind of connect the different proof of origin chains, where you can also see when people interact with each other. So it's those intersections that are almost more important in many cases than the actual data. Just kind of like the real world, where just having your story in a vacuum without any other characters in it is not as interesting as if you see how you overlap with other people's things. It's kind of one of the views I had starting my company back in 2012, was this idea that everybody is stuck inside this bubble, as I call it, where you can't leave the bubble of which you're in. You walk around and can interact with other people's bubbles, but the set theory that's behind your data set that kind of defines you as a person is something that really fascinates me. And that's really what XYO is based off of is, you have your own set of data that's sovereign, and each other person has their set of data that's sovereign. But in many cases, those sets interact and they overlap. And so those overlaps are where they co-sign the same thing. And so looking at the system as far as how do all these people's lives and all these data sets affect each other is interesting. And like Facebook does some of this stuff where you can tag people in a photo. And so there's multiple people, but who tagged them? Where did that data come from? Is that really true? I've definitely tagged pictures of a car with someone's name, for example, which is, I'm pretty sure that car was not that. But there's no verification that that person actually said, yes, that's me.
Right. It's interesting. I recently wrote an article about using Web3 technologies to verify election data, because obviously this upcoming election is going to be huge, one of the biggest, they're saying, in history. So can we talk a little bit about that? Can the XYO network be used to verify election data? So for instance, or even just election content in general, it was with Biden where there was a deep fake robocall of his voice. So I think now Web3 technologies have the capability to show that that actually was not someone like President Biden on the phone, but it was actually a deep fake. So does the XYO network have the capabilities to verify election data and content around elections?
It definitely does. It would take some infrastructure because, like in the case of the Biden phone call or robocall, what you have to do is the person who receives the call has to have a way of verifying the signature of that data. So, for example, if that call was signed by a party and then that signature was not actually, the public address was not President Biden, then you know it's not from him, right? Or you could have a chain where it could be from his press secretary, and he signed the thing that said that his press secretary can send it out. But if you have this chain that goes back to him, you can say, okay, well, yes, he was at the source of that. And even if you look at the lawsuits that are going on now about the previous election and those things, in many of those cases, there's a lot of he said, she said, right? People are like, well, we never said this, or I think it just came out today that there was some Twitter account that was a fake Twitter account that one of the people were using, but they denied that they had a fake Twitter account during their previous testimony or something like that. And so it would be nice to have a system where the only way you can create a Twitter account is by actually signing it with your address, so we can see well who created this Twitter account. But right now, if someone, I have this problem all the time on Telegram or a lot of social things where people make fake names with Arie Trouw, and fortunately for me, I have a pretty unique name, so it's easy to tell. Well, that's probably not a real person. But if my name was Bob Smith or something like that, well, you can't just stop people from calling themselves Bob Smith. But well, which Bob Smith are you? And so the only way to do that really is to sign something with a cryptographic signature and then be able to verify it. But a person answering a phone, unless your phone is equipped with that and can tell you, this is not actually from the person who you think it's from, they won't know. They have no way of verifying it. So you have to figure out, well, how do you actually get that sovereign verification mechanism in the hands of the people who are potentially going to be fooled by that sort of a call?
Yeah, definitely. And I think that's a challenge because people aren't used to this idea of sovereign data or the sovereign internet. So it's going to take some time for us to get there.
But I think people are getting more used to the fact that AI is out there and deepfakes are out there, and that they have to be more cautious about believing everything they see.
Definitely. I mean, and there's been a lot of arguments made lately saying that blockchain is really the only technology that can combat deepfakes. Do you think that that's true?
It's the only technology we know of right now, but I would expand it more to cryptography as opposed to just blockchain. Blockchain is obviously important for sequencing. The idea of blockchain is, you can't change the past because the hash goes into the next blocks. So you have the permanence aspect of that, or the immutability aspect of that, which is great. But then just even the signature, I can tell if a payload or a datagram came from somebody if they sign it with their Ethereum address, for example. Now, one of the difficulties, of course, that people have found out the hard way is that if you lose your signature or your private keys to make those signatures, it's gone forever. You can't. No one can reset your private key for you and have the same address. So systems where a person isn't at risk of losing. Say, for example, we sign things by President Biden of all these robocalls, but then he suddenly loses his private key. Well, that would be problematic because now he can't sign anything saying that it's actually him again, right? And so figuring out a way for him to have a series of private keys potentially where you can change her over time and still believe it's him, or a verification. I think WorldCoin is trying to do some of this also with the retinal scans, where it's like, well, how do I prove that this thing came from this person? Well, do the retinal scan. So, actually attaching it to a human being is one of the challenges that people are really trying to do.
Right. Is XYO Network looking into doing something like that in the future?
We definitely want to partner with companies that do that. We're not a biometric company at all. There's biometrics obviously in your phones with fingerprints now. I don't think we really want to get into the biometric space as such, but we definitely want to utilize biometrics as a way to be able to provide additional security on there. And so if a person does a retinal scan, for example, and gets a certain ID or certain hash from that, using that as a way to prove that this person was physically there as well, is definitely an interesting thing for us to do. But I think we'll definitely partner for those, because the hardware aspects of it is in many cases much more difficult to actually do than the software storage of it.
Right. What are your thoughts on the metaverse and metaverse data being generated?
So I'm a big fan of the metaverse from the standpoint that there's a lot of data already out there. I think people are thinking like, well, Zuckerberg invented the metaverse. Really, I would say the internet itself is a metaverse in many ways. You have all this additional data about yourself on social media, and in most people's cases, the social media is different than their real life, right? It's a projection of themselves with a certain filter, and so that all kind of existed there. There's the metaverse aspect, which is an alternate reality, kind of the VR portion of it, which is kind of where I think Facebook is focusing on there. I'm not a huge fan of VR personally. I find it very taxing. It's a tiring system to do, just because I think humans aren't prepared to have like that sort of a system on their head, and it's difficult on their eyes and the strain. I think at some point we'll get to the holodeck Star Trek version of it, which will be amazing. You can have a whole room where you can walk around as if you're there, but we're not even close to that just yet. But I think the AR portion of it, where like Apple's headset, to me is a much more interesting thing, because of the fact that it's primarily an overlay onto reality. So it's not an alternate reality like the metaverse as per Facebook is. It's much more of a way to layer on additional things, and it's really an extension of your phone, because people already have that with their phone. Now you can walk around with your phone. You have information about all of humanity. You have the Wikipedia entries. You can use a camera in many cases to actually go scan things. Google has that where you can scan a sign, it'll translate it for you, or it'll give you context for that. So we kind of had a lot of those AR things, but making it so it's visually available for a person on preferably a smaller scale than just these giant goggles they have. I was a big fan of Google Glass, actually. I was surprised Google Glass didn't stay around, because I thought that form factor was amazing.
Right. Have you tried the new goggles?
I've not tried the Apple one yet. I've seen demonstrations of it. It looks pretty amazing.
Yeah, it does. I've seen a few people in San Francisco walking around with that, so I want to try it out.
Yeah, I've seen that, but also I saw a video of somebody doing that, but then they get distracted by what's on there and they stop in the middle of the street.
Oh,
which is like, well, you have to still be aware of the fact that you're in San Francisco. So I think people's minds, it's hard to actually focus on multiple things at the same time. So if the additional things that are around you in this metaverse is too engaging, it could become a very hazardous thing for a person like wandering around in the physical. You even saw this with Pokemon Go. People were walking off cliffs here in San Diego trying to catch Pokemon, and that wasn't even a goggles situation. It was just a phone. They're looking down at their phone trying to catch a Pokemon, and then they walk off a cliff at the beach. So getting people to not be careless with this technology, I think, is going to be a little bit challenging.
Definitely. No, I agree. And I mean, we see it with all new technologies. I mean, we've seen all these incidents now with Teslas and then the other self-driving cars. I'm blanking on the name, but I think they've been banned, or they were big in Austin and in San Francisco, and now we're not seeing them as much anymore. I forget the name of those cars.
Oh, the taxis, like the automated taxis? Yeah, I saw it in San Francisco. They made traffic jams after a while because they would be too polite to each other. And
right. So every technology has its challenges, but I think when it comes to sovereign data and the sovereign internet, switching back to that topic, it's really important for the world to understand, why we should switch to that model versus what we're doing today, right? Because data is extremely important.
Yeah. Well, I think also, as we're seeing now with Web 2, Web 2 is much more long on the tooth as far as like its age goes. And I think the problems that are coming along with it, whether it's deep fakes or it's people losing data or large companies controlling large portions of data and that sort of thing, I think there's going to be a reckoning at some point where we have to solve those problems one way or the other. And I don't see a different way to solve it than a sovereign internet, or at least much more sovereign solutions for how people support their own data. But it's kind of the same back and forth between thin client and thick client that we've had over the years in computer science. I've been using computers since the 70s. So for me, I've seen the thin client, thick client back and forth quite a few times. And I feel that this is kind of the same thing here, where we're moving from the thin client, which was the Web 2, back to the thick client, which is Web 3. But Web 1 was kind of thick client as well.
Right, definitely. Would you say that on-chain domains fall into the sovereign internet model?
Yeah, I think it definitely does,
Okay.
because it's controlled not by a central authority, but it's controlled by a smart contract or a program that's there. And we are going to be launching something similar to ENS for XYO called XNS, where a person can have a name, a friendly name, basically, for their addresses. So that way, when I want to connect to somebody else's computer, I don't have to type in an entire address. I can just type in their friendly name, and then we can resolve that programmatically. But the idea of being able to validate whether or not it's true programmatically by going to a shared ledger is something which is very compelling, as opposed to, I don't know if you've ever traveled to China, for example, but in China, if you ask their DNS to resolve Facebook, they might give you a different IP address than the actual Facebook, right? And so you might be going through either some sort of a sniffing protocol or God knows what you're going through. So you have to trust your ISP to give you the correct URLs. I know ISPs have gotten in trouble for also, like, if there's a domain or a DNS that doesn't exist, instead of giving you back an error page, they give you back ads, which is a little bit nefarious. And so you're trusting them to actually resolve that properly for you, but it's a central authority. So I think decentralized naming services is a very important part of the future of a sovereign internet.
Yeah, I agree. And I mean, I don't know if you probably did hear the news with GoDaddy, with them supporting the ENS domains. I think that's
recently that they added on there.
Yeah, that's a huge step in the right direction for just bridging the world of Web 2 to Web 3 to this new idea of a sovereign internet model.
Yeah, I was trying to figure out, like, what value does GoDaddy actually provide to that? Is it just a simpler UI for a person to be able to register their ENS? Because once it's registered and you own a certain hash of a string, it's on the blockchain. So you don't really need GoDaddy to renew it or anything like that, but they might just give it an easier way for a person to use a credit card to pay for it, as opposed to having to pay for it with Ethereum, is my guess.
Yeah, exactly. So you don't need to type in that whole Ethereum address, and you can just type in the .eth, right? Mm-hmm. On GoDaddy. And so I think, we're starting small, right? But it's actually a big step in the right direction, I think.
Yeah, it's a good place also where, like, Web 2 and Web 3 are kind of meeting, because that's really what we need. More and more places where there's like a natural scene between the two, and it just kind of flows.
Definitely. Great. Well, Arie, we're running low on time. So any final thoughts?
No, it's just, I think people need to be aware of their own data, and they need to be a little skeptical of how their data is being used and who's storing it, and the risks of potentially losing it, and think about in the future how they're going to get around that. And I think the sovereign net is clearly the way to do it. What exactly the sovereign internet is, there's probably several different answers for that, but at XYO we have a very specific vision of how that is, and we think we have a very strong approach to it.
Right, definitely. I agree. I mean, XYO Network has been around for a very long time, and I'm so happy to see all the innovation that's been made.
Well, thank you very much, and thank you very much for having me on today.
Thanks, Arie. Before you sign off, how can our listeners get in touch with you? Do you use Twitter or LinkedIn?
I primarily use Twitter as far as communicating with people out there, so you can find me pretty easily on there. I also have my domain name, arietrouw.com, so if you just go there, I'm pretty easy to find because my name is fairly unique. I think there's one other Arie Trouw in the United States, with a physician in Indiana or something like that. But I'm pretty easy to find, and on my website you can see my socials on there. But Twitter is probably the one I interact with the most.
Great.
Oh, sorry, X. I can't.
X, right? Yeah, I keep saying Twitter. I'm sorry. It is X. You're right. I've said Twitter also. Wonderful. Well, Arie, it's been a real pleasure having you on, and I look forward to staying in touch and hearing more about XYO Network in the future.
Well, thank you. Thank you very much.
Thank you, Arie. Bye.
All right.
Special thanks to Aaron Bender for producing Web3 Deep Dive podcast. I'd also like to thank the sponsors behind Web3 Deep Dive. Finally, thanks to the listeners for tuning in. Please be sure to subscribe, like, and share. I'll see you guys next time.